Hello, hello. Yes, we welcome you back again. The channel is Physical Sciences Silver Bullet, and the person behind the channel is Richard. Now we are having this question here. Okay, let us go through the question a bit and we see what we have. We're having, we say Elana adds a sample of calcium carbonate to 50 cubic centimeter of sulfuric acid. Then what else do we know? The sulfuric acid is in excess. That one is very important to note, and has a concentration of 1.2. The reaction is allowed to continue until all calcium carbonate is used up. The sulfuric acid left over is neutralized by 30 cubic centimeter of 0.5 moles per cubic decimeter sodium hydroxide. So calculate the mass of calcium carbonate in the sample. Now let us actually first discuss this question and we'll see what it requires. Okay, this is what we know. We have a reaction. The reaction is between calcium carbonate and sulfuric acid. When this one reacts, what are the products we get? We get calcium carbonate. Okay, sorry. We get calcium sulfate. Both are valence 2. Calcium sulfate plus water plus carbon dioxide. So this is the reaction we get. Now, we have also to remember that sulfuric acid was oversupplied, so we have excess here. Now, this is what we are having. Now, when you look at this question, this is what you have to remember, that it is sulfuric acid which is going to be our guiding light. It was supplied. We know the total which was supplied. We know the total number of moles of sulfuric acid. We know the total which was supplied. Total supplied. We know. Okay. Because once somebody gives you concentration and gives you volume, that one is a known case. So those number of moles are known. What else do we know here? We know the excess. We can get it indirectly because it reacted with the known number of moles of sodium hydroxide, so we can get that one. So when you have the total number of moles of sulfuric acid supplied altogether, and you have the number of moles in excess, so you can easily get the number of moles, of sulfuric acid which reacted. So this is the sketch which you will have to know. Let me repeat. This sulfuric acid, we know the number of moles which was supplied because they gave us the concentration. And we know the number of moles in excess. We can get it through indirect method. So this reaction here in chemistry, we call it back titration. So when you have this and you have this, therefore you can get this, because the entire setup is meant to guide you to getting this. Once you have this, it's game over. So let us see the procedure we can take to get to the answer. Please don't forget to subscribe. So this is what we get from the discussion we had. Your sulfuric acid was supplied, and this number of moles are known. We are going to get them. The supplied sulfuric acid, it's divided into two parts. Part of it reacted with calcium carbonate, and part of it is in excess. So let us see how we can go over this one. You have the total number of moles of sulfuric acid supplied. Why? Because they gave you the concentration, which is 1.2 moles per cubic decimeter. They gave you the volume, which is 50 cubic decimeter, but I can divide it to get cubic decimeter. It was in cubic centimeter, now you get 0.05 cubic decimeter. Now, in a case where you have concentration and volume, it means you have the number of moles through the equation, which is equal to C is equal to N over V. Concentration is equal to number of moles per unit volume. And the concentration is known. It's 1.2. Number of moles are needed. Then the volume is 0.05. So what do we get as our N after computation? We get it as 0.06 moles. These are the total number of moles of sulfuric acid added. Okay. Now you have to, this part is done. Now we are coming to this one. So we are going to calculate the number of moles of sulfuric acid in excess. And this space is not enough, so we are going to go to another page, but we will come back to this formula. I want to remind you that if you have the total number of moles supplied and we can calculate the number of moles in excess, then we will be in a position to get the number of moles of sulfuric acid which reacted with calcium carbonate, because this is what we are looking for. The entire setup is directed at getting this number of moles. Okay, there we are, calculating the number of moles of sulfuric acid in excess. So this is what we have to remember. You have to remember that the sulfuric acid which was in excess reacted with sodium hydroxide. So the products are going to be the salt, sodium sulfate, sodium sulfate plus water. So when you reach this stage, what you have to do next is to balance. The sodium is 2, so you put a 2 here. And when you do that, you have hydrogen, which is 4, so you have a 2 here. Now, the equation is now balanced. the next stage, when you use the simplest method ever, what we normally do, we divide this one into two. This side, let us put sulfuric acid. And this side, let us put sodium hydroxide. The entire setup is about this and this. So we quote the mole ratios. Sulfuric acid is having 1. Where do we get the 1? The number which is in front here is what we put here. Sodium hydroxide is having 2 because of this 2 here. Now, when you reach this stage, then you start from the known. We normally move from known to unknown. The known is sodium hydroxide. We know its concentration, which is 0.5 moles per cubic decimeter. And what else do we know about sodium hydroxide? We know the volume. The volume is 30 cubic decimeter, and which we can convert to cubic decimeter by dividing with 1000. So it's going to be 0.03 cubic decimeter. So like I said before, when you have carbon, when you have concentration and you have volume, then you have number of moles. The equation is very straightforward. It says concentration is equal to number of moles per unit volume. So when you have here, what do you have? 0.5. And what do you have there? You are looking for number of moles, but you have the volume, which is 0.3. So this one will give you the number of moles. So after cross multiplying, what is the number of moles? It is going to be, so now we have our number of moles of sodium hydroxide which reacted, and they are 0.15. So what is next? What is next is to use the known to calculate the number of moles of sulfuric acid which reacted. And you have to know that these are direct proportional ratios. So we are going to cross multiply. When you do that, we multiply 1 with this one and 2 with this one. We get 1 times 0.015, which is equal to 2 times n. So in this case, our n is going to be 0.015 over 2. And we get, so these are the number of moles we get, which is 0.0075. So what we have here are the number of moles of sulfuric acid in excess. So after getting them, what do? We go back to that formula. So like we discussed before, this is the formula. The formula simply says that the total number of moles of sulfuric acid which you added, part of it reacted with calcium carbonate and part of it is in excess. Now we know the number of moles of sulfuric acid which we added. We found them to be 0.06 moles. And we have just found the number of moles of sulfuric acid which are in excess, which are 0.0075. Now, knowing this and this, then it means that this one is now known, and it's going to be 0.06 minus 0.0075, which gives you. Now we come here, so we know the number of moles of sulfuric acid which reacted with calcium carbonate. So what do we do next? Next is that now we see this reaction. What's the reaction? The reaction is between calcium carbonate reacting with sulfuric acid. The products are this calcium sulfate plus water plus carbon dioxide. The next thing you do is to balance. Let us check and see. So it looks like it's balanced. So it's balanced. So in this reaction, what do we have? This is what we have. This reaction, we divide this one into two for easy handling. And we look at the mole ratios. For calcium carbonate, it is 1. Like I told you, you look at the number here. Now for sulfuric acid, it's also 1. So the mole ratio is 1 to 1. So what is the next step? The next step is you look at this. What do we have here? These are the number of moles of sulfuric acid which reacted with calcium carbonate. So you put it here. It is going to be 0.0525. So if the mole ratio is 1 to 1, it means that we know this one also, which is the same. So it's also going to be 0.0525. This is the number we have been looking for all along. Now, after getting this number, what do we do with it? Okay, let's squeeze our next work here. Hopefully it will be enough for us. So we come to our calcium carbonate. What do we know about it? We know the number of moles of calcium carbonate, which is 0.0525 moles. What else do we know? We know the molar mass of calcium carbonate. Let us see, it is 40 plus 12 plus 16 times 2. Then after getting that information, we are looking forward for mass. And the equation says number of moles is equal to mass over molar mass. So when after computing here, the number is 100. So the molar mass of calcium carbonate is 100 grams per mole. So what do we do under this circumstance? You substitute. You substitute for N, which is 0.0525. You substitute for mass, which you don't know, but molar mass is 100. From there comes our final answer, which is going to be, let me see, It's going to be 5.25 grams after cross multiplying. So this is it. It was a marathon, but it's doable, especially if you follow our steps. Thanks very much, and don't forget to subscribe.